Hello, welcome to ANS Solver. This is the eighth question of the paper, and as you can see, this is a partial fraction question. So, here, what we need to do basically is, looking at the denominator, because this cannot be factorized, the form is simply a over 2x minus 1 plus bx plus c over x square plus 2. Now, I can simply take the LCM here. So I can write this as a into x square plus 2 plus bx plus c into 2x minus 1. Okay, so now what I can do basically is, let's say I want to find a. Now to find a, I know this full part needs to be 0. That means I can equate 2x minus 1 to 0. So for finding a, I can equate 2x minus 1 to 0. So I'll get my x as half. So now I'll get 2 into half square plus half plus 8 equals to a into half square plus 0. So now what I can simply do is, I can write this as 2 into 1 over 4, which is simply 1 over 2 plus 1 over 2 plus 8 equals to a into 1 over 4 plus 2. Now what I can do is, I know this is equal to 9 equals to 1 over 4 plus 2 is, I know in fractions it can be written as 9 over 4. I can simply cut the 9 here and I can get my a as 4. Now what I need to do is basically, I can write the same equation down, 2x square plus x plus 8 equals to 4 into x square plus 2. Instead of a I put 4 plus I can expand bx plus c into 2x minus 1. So this is bx into 2x minus 1 plus c into 2x minus 1, which now I can write as 2x square plus x plus 8 equals to 4x square plus, I know 4 into 2 is 8, plus 2bx square minus bx plus 2cx minus c. Now what I can do is I can adjust 2x square plus 8 plus x plus 8 equals to 4x square plus 2bx square, okay, plus 2cx minus bx plus 8 minus c, keeping all the x's together and the constants together. So now I can adjust 2x square plus x plus 8 equals to 4 plus 2b, and I can take x square common plus 2c minus b, and I can take x common plus 8 minus c. Now I can simply compare the coefficient of x square here and the coefficient of x square here, which is basically 4 plus 2b equals to 2. Then the coefficient of x here and the coefficient of x here, which is 2c minus b equals to 1. And the constant here and the constant here, which is 8 minus c equals to 8. So now what I can do is, I can adjust 2b equals to 2 minus 4, which is minus 2, and b equals to minus 1. So now this is 2c minus 1 equals to 1. So this is 2c plus 2 equals, 2c plus 1 equals to 1. So I know 2c here is equal to 1 minus 1, which I know is 0. So I get my c as 0. So now I can basically write the partial fraction as a over 2x minus 1. I know my a is 4, so 4 over 2x minus 1, okay, plus, or I can write minus, because this is minus 1 here, so minus 1x over, because I know c is 0, x square plus 2. So I can write this as 4 over 2x minus 1. Sorry, my bad. Yeah. 4 over 2x minus 1 minus x over x square plus 2. This is basically my f of x in partial fractions. So my c is 0 here, my a is 4. Yes, so this is the second part of the question. So what we basically need to do is we need to integrate f of x with the limits 1 and 5. So now what I can do is I can split this as limits 1 to 5 with 4 over 2x minus 1 minus the limits 1 to 5 with x over x square plus 2. So I can write basically dx and dx. So now what I can do is I can split this like this. Now the integration of 4 over 2x minus 1 is simply, first I can write ln 2x minus 1, but there's a pre-existing 4 over the coefficient of x, which is 2, with the limits 1 and 5. So now I can write this as 2 ln 2x minus 1, okay, with the limits 1 and 5. So now in the place of x, I can first put 5, which is simply 2 ln 5 into 2, which is 10. Okay, and 10 minus 1 I know is 9. Minus 2 ln, I can do again 2 into 1, which is 2. 2 minus 1 is ln 1. So I'll basically just get it 2 ln 9 because I know ln 1 is 0. Now for this, how do you integrate something like this? I can't use partial fractions, I can't use by parts. So the only thing I'm left with is integration by substitution. Because when I differentiate x square plus 2, I know I'll get something in x, which can get cancelled with the numerator. So I can take my u basically as x square plus 2 with my du by dx basically as 2x. Okay, so now I get this as du by 2x equals to dx, which can basically be written as, I can't write the limits now because I'm writing everything in terms of u. So this is x over u into, instead of dx, I can write du by 2x. And simply cut the x's to get 1 over 2 multiplied with the integration of 1 over u du. So this is basically 1 over 2. The integration of 1 over u is simply ln u. Now I can write this as 1 over 2. Now instead of u, I can simply write x square plus 2 with the limits I know, which is 1 and 5. So now I can basically write this as ln. Okay. When I put 5 in the place of x, I get 5 square plus 2, which gives me ln 27. Minus, when I put 1, I get 1 square plus 2, which is ln 3. So now what I can do is I can use a log property here, which suggests that log a minus log b is equal to log a over b. So I can simply write this as 1 over 2 with ln 27 over 3. So now I can write this as half ln 9. Okay, got it? Now what I can do is simply I can write this as 2 ln 9. Okay, then a minus here because of this, minus half ln 9. Now an important log property I can use here is that b log a can be written as log a raised to b. So using this log property, I can write this as log 9 raised to 2 minus ln 9 raised to half, which can be written as log, sorry, just 1 second, this is not ln, this is log, sorry, this is ln. So I can write this as ln 81 minus ln 9 raised to half is ln 3. Now using this property which I wrote here, log a minus log b is basically log a over b. I can write this as ln 81 by 3, which can be written as ln 81 by 3 is simply 27. So I have written this in the form of ln c. So I can say my c is basically 27.